This video will be a continuation of what we just did. We just did the rational zero test, and you're seeing the last problem that we did. Now I'm going to take this information that I got using the rational zero test, and I'm going to try and find all of the possible roots of that particular polynomial function. First thing I'm going to do, though, is I'm going to go ahead and set up my calculator, which I already have. I'll set up my calculator. I will type in that function into my y equals. I'm just going to double check to make sure I typed everything in right. 10x cubed minus 15x squared minus 16x plus 12. I did. Then I'm going to do something a little bit different. I don't know if you've ever learned this, but I'm going to set my table up in a different way. I'm going to hit my second button, and then right above the window button, you see where it says TBL-SET. That's your table settings. I'm going there. And I am going to change the independent auto over to independent ask. And what this does for me is it gives me a blank table, and all I'm going to do is I'm going to type in these numbers one at a time. Now there's a lot of numbers to type in, and I do want to let you know that I don't have to type every one of them in. But what I'm trying to figure out is, I'm trying to figure out, will 3 of these work for me? Because I will have a maximum of 3 possible zeros. So I might have to type them all in, but we'll find out. Okay, so I'll type in a 1. Okay, so remember your fundamental, your remainder theorem? If I divide by 1 and get a 0, then that means that this is a factor, or this would be, or positive 1 would be one of my zeros. I did not get that 0, so I'm going to keep on going until I find 1. I just want 1, matter of fact, to be honest with you. I just really want 1. So I typed in a 2. There it is. So positive 2 is going to be one of my solutions to this function. Now, why do I only want 1? Because when I take that 2 and I divide it into my function, then remember you can't see that. If I divide that into my function, remember that reduces that function down to a second degree function. This is a third degree right now. If I can reduce it down to a second degree, that's a quadratic, and we all know how to solve quadratics. I will use synthetic division. I'm not missing any terms, 3, 2, 1, and that's a degree of 0. So I'll write out my coefficients and finish off with my constant. This better be a 0, or else I did something wrong. All right, so remember synthetic division. Bring down your first number, multiply 10 and 2, put it right here. Combine, multiply 5 and 2, put it right here. Combine, multiply -6 and 2, and there's my 0. So remember, this started off as a third degree polynomial. I will end up with a second degree polynomial, which means this is going to be 10x squared plus 5x minus 6. This is a root, so its factor is x minus 2. So remember, the only way for it to be a root is if I take it and set it equal to 0. X minus 2 equals 0, that means x is equal to positive 2. So this is what it looks like, reduced down to a quadratic. I will go ahead and tell you that I'm pretty sure this is not factorable. Let me think about it for a second. It is not factorable. So the only other way I can solve this is to use a quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So a is equal to 10, b is equal to 5, and c is equal to -6. Let me go ahead and plug everything in. Opposite of b. B is a positive 5, now becomes -5. Positive 5 squared minus 4 times a times c all over 2a, which will be 2 times 10. I'm going to write this as an exact answer. So let me go ahead and multiply 5 squared, which is 25, minus 4 times 10 times negative 6. This gives me 265. So right now what I have is negative 5 plus or minus the square root of 265 all over 20. I need to see if I can simplify 265. I'll do the prime factor tree. I think, well, not think, I'm 100% certain that, well, I know 5 will. That would be 53 times. 5 goes in 26 5 times. 5, yep, 53 times. Okay, well, 53 is a prime number, so it stops. I have my 2 roots now. Here's one, here's another, and here is your third. Okay, so there are your 3 roots. Now, if it did ask for you to round this to the nearest hundreds, then you would just type that in your calculator and go from there. And always the goal here is no matter what your function is at the start, or what degree your function is at the start, we always want to reduce it down to a quadratic, which means if this is a 5th degree polynomial, we need to try and find 3 of these so we can continuously divide synthetic division. I will do another example later on another video. Okay. Good luck.